Hey there, space weather viewers. We're delighted to bring you another daily space weather video. We're looking at 24 hours of solar activity here, and there were some coronal mass ejections. Are they earthly directed? What's going on in space? Thanks for tuning in, by the way, to the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-O-Mash, and let's break it down, shall we? We've got coronal holes. We've got a coronal hole sputtering high-speed stream. We've got NOAA forecasting some geomagnetic storm conditions and lots more. Let's take a quick trip around the horn. You may see some activity happening up here. Indeed, there was a coronal mass ejection in that from that northeastern limb. Here's a close-up. Lots of large solar filaments remain on the Earth-facing portion of the solar disk, creating a nearly 100% probability of additional coronal mass ejections. It's exciting times for space weather facts, and very profitable time for space weather frauds, apparently. There is your northwestern limb. Again, filaments are the story of the week, as there you can see filaments all over. Also coronal holes, and a little uptick in general solar activity. Things like the X-ray flux and the radio flux have both gone up marginally since yesterday. There's the western equatorial region. The most active region is that active region you see right up here. That's a series of sunspots. There are like probably over 100 umbrae in that area right there. It has also been the most active region for solar flaring, as we just had an M-class flare when we were doing show prep. So there is the current situation. Now we've also got the northeastern limb there, a great detailed view of that coronal mass ejection and plasma reorganization happening there. You can see a lot of plasma splashing back down, and some of it indeed making it out into the greater solar system. And next we'll show some sunspot imagery here. Starting out with yesterday plus today. There is your SDO intensity gram. And some degradation of this sunspot group up here. Some growth of this sunspot group up here. And this is quite a magnetically complex and rather large region. And lots of umbrae down here. Let's take a look at the magnetogram. That's also yesterday plus today, April 26th, plus the 27th to date. All right. And let's break down what's going on planet Earth. First of all, Volcano Discovery's got a great hazard diagram of the Coronal volcano. You can find that on volcanodiscovery.com. And let's see what else is erupting. So Shivaluch, back on the list now. Shivaluch exploding once again after infusing the northern hemisphere with stratospheric level volcanic ash and gas. 14,000 foot ash plume over Shivaluch, flight level 140. Subanose Jima, flight level 060. Coronal. Passive emissions and steam gas continue to emit from craters, rising approximately 200 meters above the volcano. Please do not fly your hang glider or ultralight aircraft over the caldera. Popocatépetl exploding in central Mexico, flight level 220, 22,000 foot ash plume. 15,000-foot ash plume from Fuego in Guatemala as it explodes, and a 31,000-foot ash plume there from Sabancaya. Looks like an uptick at Peru. Sabancaya exploding, flight level 310, a 31,000-foot plume of volcanic ash. And let's move to seismicity. Things have been pretty calm over the past 24 hours in terms of earthquake activity. And let's check the list here. Citing quakes over a 5 magnitude, of which there weren't many. There was a 5.0 south of the Kamchatka Peninsula there. That was at 15:41 Universal Time. Yesterday afternoon, also Greece had a deep quake there near the northern shores of the Mediterranean. A 5.1 magnitude quake there at over 120 kilometers estimated depth. That was at 2000, 8 p.m. Universal Time. 5.1 at Greece. Also a 5.1 at Indonesia 43 minutes later. And South Sandwich Islands also had a 5.1. That was early this morning at 1:55 Universal Time. Today, the 27th. A couple more 5 magnitude quakes here, like this 5.0 at Chile. That occurred at 6:07 this morning, and a 5.3 at Japan. And let's get back to space. So here is the past 24 hours in SDO 304 angstroms ionized helium, one of the classic wavelengths to view Helios in ionized helium. And it's also going to provide a great view of this limb darkening event over here. You can see some limb darkening happening there. That's something that we notice when coronal mass ejections happen. One of the many ways we're able to detect those limb darkening. Plasma there getting in between the bright regions. Great view there in 304 angstroms. The 10.7 centimeter radio flux has gone up to 137 solar flux units, I believe it is now. 137 is the radio flux, represented by this black line. We're showing a 1-year graph there from Solon.info. The red line below it is the sunspot number, and the blue line down there is the AP index. That's just an average of global geomagnetism. Space Weather Enthusiast dashboard, like we said earlier, NOAA forecasting a geomagnetic storm early tomorrow through like midday tomorrow with, quote, combined effects from a coronal hole high-speed stream and the 24th of April coronal mass ejection. Now, of course, we disagree with that. We think that's going to miss. Check out the solar wind speed here, elevated to 620 kilometers a second. We'll get to that in a minute. So there you go. That's NOAA's forecast. I think that's going to be a miss. But if that is a strike, there should be some signal there in the solar wind data. We'll cover it in tomorrow's video. Let's take a look at Earth's magnetic moment from space for the past 4 hours. It is fairly calm out there, although again we did just see a little uptick here in the solar wind. We've got a sputtering coronal hole high-speed stream. You might see some large variations here in the magnetohydrodynamic pressure out to about 12 Earth diameters. That's the past 4 hours of magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework, our Geospace Magnetosphere movie. Here's ground magnetic perturbations map as well. And just a quick reminder, if Earth's magnetic fields were really going to reverse, you would see all kinds of weird magnetic perturbations at the ground level. And guess what? You don't. We show the map every day because the likelihood of a magnetic reversal is incredibly low. And there is a bunch of nonsense on YouTube about how, oh no, Earth's magnetic poles are going to flip. I find it highly unlikely. Let us know what you think in the comments. So that was Earth's magnetic moment from the ground. KP index currently at 3.33. It is a geomagnetically calm condition approaching geomagnetic unrest. And let's take a look at the data from Lagrangian point 1 outside the Earth's magnetosphere, the ASIN Discover data, otherwise known as the real-time solar wind. So the current conditions here, again, they are over 600 kilometers a second here. 618 kilometers a second for the solar wind speed. Solar wind density here registering below 1 proton per cubic centimeter at 0.79. That's a very low solar wind density indeed. Even 2.28 protons per cubic centimeter is quite a diffuse solar wind indeed. So quite a high speed there and quite a low density. The rest of those panes are fairly uneventful. And you can see the sputtering of this. It's actually gotten a little bit more coherent. You can see the plasma temperature jumping around down there in the bottom frame. A little bit more of a consistent signal there in the past about 10 hours. Next, we'll move to the GOES magnetometer data. Now, those are inside Earth's magnetosphere at about 23,000 miles of altitude, about twice the altitude of your GPS satellite there. The GOES 16 and GOES 18 there, showing some lower highs and lower lows in the past 24 hours there on their magnetometer measurements. And those spiky readings that you see, those jagged curves there, those are consistent with coronal hole high-speed streams. And let's take a look at the heliospheric current sheet next, as coronal hole high-speed streams are streams of plasma, and that plasma is polar. At the moment, Earth is seeing a south pole current sheet depicted there in red. And like we said yesterday, there might be a bit of a delay. That might not arrive as early as it appears to there, as we've got a significant sunspot group in the north, which could delay the sector boundary crossing where Earth moves into a north pole current sheet depicted there in green. Here are our line of sight field plot. The gong magnetogram there depicted on the solar disk. Quite a bit of magnetism there on the Earth-facing portion of the solar disk. Coronal holes, filaments, sunspots, lots of features to choose from. And next we'll move to coronal holes. So there is your coronal hole line of sight plot. And let's bring up the latest image. We've got South Pole-oriented coronal holes, except for one right down there in the northeastern portion. Right down here, there's going to be a North Pole-oriented coronal hole peeking through. The first sign of the North Pole heliospheric current sheet. All the rest of those coronal holes are very well defined, and there is a huge amount of plasma here suspended by magnetic fields in the Earth-facing portion of the solar disk. So that is a reason to say the likelihood of additional coronal mass ejections is just this side of 100%. And let's move to sunspots. All right, so here is our flare probability monitor. And we've got, let's see, two new named groups since yesterday, 3291 and 3290. I don't suspect there are any more new sunspot groups, so mostly stable here as far as sunspots. Here's the past 24 hours, and we're going to show some close-ups. Today we're doing things slightly differently. You may not notice a difference. We've made some minor changes. Allow me to vanish. Here's a closer view. And let's do some sunspot detail imagery. So that's 3290, is it? It has degraded a little bit. It looks like it is still beta gamma class. It does have the type of field complexity required to produce some flares as it approaches the limb. This is the small group in the north. Here's the most active group. This is just south of center disk. Those groups there mostly stable. Some umbrae coming together right here. And if you're wondering if that's going to increase the likelihood of a flare, I would say no. Those are probably going to cancel each other out. They are very similarly sized ombre there, and they are likely of opposite polarity. So they're going to sort of hold each other in check, I suspect. And here is the northeastern limb also. Those sunspots fairly stable as well. Next, we'll look at energetic particles. No spikes in the GOES proton flux. No solar energetic particle events indeed. And the largest flare of the past 24 happened just before we created this video. Right about 11:10 universal time, we had an M1.88 class flare. The largest flare in quite some time. That's kind of exciting. Let's take a look at some wavelengths that are specifically designed to view solar flares. That would be the 131 plus 94 angstroms. We've got some additional splentacular close-ups for you here. You can see that activity there in the northeast. Here's a little closer view of that. And here's that large group right in the Earth-facing portion of the solar disk there. Again, there is the GOES X-ray flux. Peak flux was around 1110 if you want to make your own custom videos about that. By the way, today's featured product is 20% off. Do Not Pole Vault the Caldera is our best seller, I believe. If you want to get your mom a Mother's Day gift, save 20% site-wide. 20% off everything at the merch shop. And a quick public service message. If you're going through hell, keep going. Our finest days lie ahead. One of the things you may realize when you're listening to somebody speak, you might not remember exactly what they were talking about. You might not remember the details of the 10.7 centimeter radio flux or the sunspot number. What you will remember is how they make you feel. So while things can certainly get worse, much, much worse, our finest days lie ahead. And no matter how badly things get, do not pole vault the caldera. If you're going on a volcanic vacation, leave that vault pole at home. Here's what's going on overhead. Where we're located in Lehigh Valley, Pennsylvania, Jupiter's still in Pisces. I guess Zeus is still out fishing. You've also got Mercury chasing the Sun chasing Jupiter, and Jupiter chasing Saturn across the ecliptic. And if you're up at dusk, just after sunset, you'll be able to see the third brightest object in the sky. My favorite planet, perhaps besides Earth, is Venus. Here's what's going on in the solar system. We've got terrestrial planets on one side and gas giants on the other. This is your 1 week solar system forecast. And no, the planets are not going to kill you. Here's where things will be in a week on May 4th. 5/4/2023 will feature a gibbous waxing moon as we approach the May full moon coming early in the month. And let's move to coronagraphs. So there are yesterday's coronagraphs. You can see quite a substantial coronal mass ejection there. And we don't suspect that would have an earthly directed component there. It looks like it's well off to the northeast. We don't see anything resembling a halo there, but another great example of a CME with a core. You can see that core there. Let me pause that. A great example there. You see this outer shell right here. And then you see this core region, which can have completely different magnetic properties. You can also see shells here on the sides. As those plasma The plasma in the core of that thing can have a completely different series of characteristics than the outer portion of that. Those are yesterday's coronagraphs. We've also got some frames from today. Those are also pretty unlikely to have any earthly directed components. And let's take a look at stereo A, located just a few degrees behind Earth at the moment. And there you can see stereo A on the left, the Soho Lasco C3 on the right. Quite a substantial series of coronal mass ejections there, happening midday yesterday. And then also additional ones today. Let me bring that back. I'll pause both of those and get a good still frame for you. Here's the most recent one. That's 5:06 Universal Time on the Soho Lasco C3. There at 8:30, you can see quite a bit of material continuing to come out there, and then a little bit of a stretch of missing data on the Soho. Anyway, let's continue on. I'm going to show you some 193 angstroms SDO imagery here. Another 24-hour video for you. And what's next? Let's pause for station identification. You've reached the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. By the way, thanks to everybody who tuned into our 15-hour live stream yesterday. The next thing we'll talk about is solar filaments. Again, there are still a large number of solar filaments in the Earth-facing portion of the solar disk. Not as many as we had yesterday. Some of them are very dense, as you can see, like this one's setting in the west and this one in the northwest. Also some new very dense filaments. This is the Remco Evenepoel filament, the winner of the Liège-Bastogne-Liège World Cup race, taking place on Sunday, which is, I believe that's the final of the Spring Classics. And if you're a cycling fan, why not check out our driving, riding, and pro tips playlist on the YouTube channel, youtube.com/smashomash/playlists. That is the filamentary situation from our El Teide, Spain ground-based solar observatory. Make sure you follow us on Twitter, by the way. If you don't have an account, follow us over there. Don't forget to follow the hashtag #NameThatFilament. And here are the past couple of hours from the GOES 16 SUVI, and that M-class flare did indeed come from this sunspot group down here. It's a little tough to see it there, but indeed right there you can see that M-class flare showing up, the southern portion of that sunspot group. We'll zoom out a little bit to show the extended corona. One of the great features of the GOES 16 SUVI is that ability to see CMEs. It's got a wider field of view than the SDO and a little bit lower resolution. Here's the past 24 hours in 304 angstroms. And let's get back to our bonus features segment. So now we're talking about satellite charging hazards. We do see some surface charging there in the Pacific Ocean. Those low-energy electrons are building up on the outsides of satellites at the moment. Could cause some minor communications breakdowns there. Low-energy electrons there building up on satellites, causing surface charging hazards in the Pacific. The electron flux here a little bit higher than NOAA expected. That's a 3-day graph. That is radiography performed by the GOES 16 and GOES 18 from their geosynchronous orbits. They measure the electron flux at the F layer of the ionosphere, which we will also show you momentarily. First, the forecast. NOAA expecting a continued uptick in the electron flux following the longest trough in a year. There is the 1-year graph to put it in context. You can see that lengthy trough just a few days ago there. And we'll show the vibration of the F layer, one slice of the atmosphere. Feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation, atmospheric temperatures at solar max and minimum, or molecular concentrations of the atmospheric layers. Here is the F layer, and things are calming down here following that strong geomagnetic storm, which, by the way, was almost exactly what we forecasted and almost exactly when we forecasted it to arrive. We forecasted a KP8, which is exactly what we saw, also a rather short duration. One thing we couldn't forecast is the neutrality of the core of that coronal mass ejection, but the core was pretty weak. The outer lips, as they're known, featured much stronger magnetic fields, especially the trailing lip, where it got as high as 30 nanotesla, likely pulling a bunch of material into the Earth system. Anyway, there's the previous day of the F layer. And we'll also show the anomalygram next. There's the anomalygram. Anomaly in megahertz from a 30-day median. And things getting much more normal here as the ionosphere puffs back down to its normal size. It was extremely puffed up for the past couple days, and it still is quite puffed up, just not nearly as much as it was, as the ionosphere attempts to reach static equilibrium, a feature of most forces in nature. One might even say all forces in nature are trying to reach static equilibrium. And we'll briefly show the latest image. There is 1215 universal time ionogram and 1215 universal time anomalygram. Low-frequency anomalies dominating the situation, likely higher density occurring there in the ionosphere. Feel free to pause the video on this frame if you're not familiar with distances in miles. We'll show the total electron content, the free electrons out to about 12,500 miles of altitude, the location of your GPS satellite. So there's the total electron content. It'll show you the most likely places to see errors in your GPS caused by free electrons refracting your signal. And things are looking pretty normal here for the total electron content. It stands for the coupled thermosphere, ionosphere, plasmasphere electrodynamics, as there are many layers between your GPS satellite, the inner portion of the outer Van Allen belt, plasmasphere outer, inner Van Allen belt, plasmasphere inner, and the ionosphere can all refract your signal. Here's the latest intensitygram and latest solar magnetogram. Do we have a new sunspot group there? Nope. But this may be named a second group. I believe that actually is a second group. Let's check the polarity there. I think that's a second group personally. Let us know what you think in the comments. This one's got a North Pole leading umbra and some South Pole trailing umbrae. This one here is just an alpha class sunspot at the moment. I only see one umbra there. That's my story, and I'm sticking with it. There's the full disk rock back. And it's time to go to meteorology. So we don't just do the space weather, we do the Earth weather as well here at the Smash News Network, least busted name in news. And we're going to start things out by looking at sea surface temperature anomaly. So this is going to show you sea surface temperature anomaly as well as currents. And we're starting out with the South Geographic Pole. At the moment, Antarctica is surrounded by cold water as winter approaches. A bunch of warm water there to the east of New Zealand. as you can see there. And let's check the sea surface temperature and currents of the Indian Ocean. The sea surface temperature is the shaded portion. The animation would be the currents. How about the Arctic Ocean? Some anomalously cold water there around Greenland. Not sure why that's even showing up as water, as a lot of that is ice. I guess ice is anomalously cold for this time of year. I don't understand what the reasoning for that is. Here's the Atlantic Ocean. Some very cold water here in the Gulf Stream. That's like 13 degrees Fahrenheit below normal. And also some very warm water here. So could be caused by things like snow melt. And you can look at the animation there and see the Gulf Stream is still making it to Ireland. So if you're worried about a year without a summer in Europe, you're worrying for absolutely no reason. There are the sea surface temperature anomalies and currents of the Pacific Ocean as La Nina breaks down. And let's take a look at things like surface winds. So there are the surface winds of the eastern world. Shout out to our viewers from all around planet Earth. There are the jet streams. Perhaps the single best signal to forecast global weather patterns. The jet streams of the West, aka the Americas, are looking like this. Doubled up jet stream over the eastern U.S. And these are the surface winds. North Atlantic remains stormy. Here are the surface winds of the central world. And, like sands through the hourglass of time, these are the jet streams of your lives. Clouds and fog over the Americas, depicted here by the 3.9 micrometer radiation map. It shows clouds and fog even at nighttime, so if you're aurora hunting, which you're likely to be doing soon, although there are no major CME impacts expected, you can use the shortwave radiation map to determine whether or not you've got clear skies. Although you could go out and see if you can see stars too. That also works. Here's your weather.gov map. Weather.gov. If your location is lit, click your location. We've scrolled down to show you the key, and we've got some severe thunderstorm warnings around the Gulf Coast. An area that has been getting hit repeatedly. Weather.gov. If your location is lit, click your location. And here is your pressure and precipitation forecast. There's a second severe system about to move in as cold air pushes down from Canada once again. It'll start out in Texas, southeastern Texas, and then hit the Gulf and then make landfall once again. So that's going to be another pretty significant system. Also northern Mississippi, expecting to get hit there. That's your 72-hour GFS pressure and precipitation forecast. We'll also show the temperature anomaly forecast. Major meltwaters coming to the west as there is huge snowpack there. We'll show it here in a minute. That's your temperature anomaly, GFS 72-hour forecast. It is in degrees Celsius. And let's take a brief look at windy.com's map. So we're showing humidity here. And let's switch to snow depth just to show you how much snow there is remaining to melt. Quite a bit indeed. So those high temperature anomalies come into those areas. We'll be producing some significant meltwaters indeed, so be aware of that. And let's see the teeth of the storms here. So there are your lightning strikes, your likely visible lightning there depicted on our NASA GOES lightning mapper there by that is the GOES 16 East. And how about a real-time lightning map before we show things like Doppler radar, clouds and fog, and the water vapor. So there are a severe thunderstorm there to the east of Baton Rouge. A more minor thunder shower there south of Houston, it looks like. There's your full map showing active lightning. Next time you hear thunder, check it out. Lightningmaps.org, highly recommended. Here is your U.S. Doppler radar. And rather than the full 50 states view, we'll show the lower 48 view. As we tie things together, there is the clouds and fog view, 3.9 micrometer infrared radiation. And there is the water vapor map. Like we said last night, this impulse of dry massive air here is kind of taking its time. Also, there is cold air pushing down here from Canada. So there's some multiple impulses there happening. And yeah, those systems are moving very slowly. And here's your recap. The U.S. Doppler radar. Clouds and fog. And don't forget water vapor. That should clear things up. When your Doppler is not making sense to you, try out the water vapor map. Thanks for tuning in, by the way. And if you enjoy the content, help out the channel. One of the things you can do is by picking up items from the Hemp Lucid shop. You can find links below the video. Don't forget to enter the promo code SMASHOMASH to save some dough. There are the most popular items, the CBD tinctures. The water-soluble being the most popular on the Hemp Lucid site. Tastes great, less filling. You can also help out the channel by becoming a member of the Smash Team at smashomash.com/SmashTeam. There is a bronze level which costs you $0 per month. There's also a silver and a gold level. These videos are brought to you in part by our silver and gold level Smash Team members. The best value is the gold annual paid-up subscription, as it includes complimentary merch. It's like getting 4 months of the gold membership for free. You can also get an @smashomash.com email address, smashomash.com/SmashTeam. Once again, thanks to the Smash Team, and welcome to the Neo Renaissance. You can find links on the homepage as well as below the video. Smashomash.com is the homepage, so why not visit us over there? Thanks to everybody who has supported the channel. Shout out to each and every one of you. Congratulations on realizing the channel exists. We'll see you soon, probably with another live stream. Remember, folks, I'm not only Smash-O-Mash, I'm also a client. And if you're using the word Google as a verb, it means to obtain biased search results using the Google Junkware search engine. Let me use it in a sentence. I Googled it, and now I know less about it. We'll see you soon. In the meantime, may that solar wind be at your back.